Hi everybody, thanks for watching today. Glad you're watching. Today we're doing 4.2 notes. We're solving quadratic equations by graphing. If you haven't already, take a minute and pause the video and do the starter questions, and then unpause it when you're done. Okay, so on to number one on the notes. Once again, here are all the ways you can solve quadratic equations. Factoring we did yesterday, graphing's today, and then there are a few more coming up throughout the rest of the chapter. By the end of this chapter, you'll have plenty of ways, plenty of tools in your toolbox to solve a quadratic equation. Number two on the notes, before we start graphing, talk about a slight difference between quadratic functions and quadratic equations. Here is what a quadratic function would be, and here is what a quadratic equation would be. As you look over those, probably right away you notice that one has a y equals and one has a 0 equals. Quadratic functions, they have y equals in them, and we use those mostly when we're graphing or analyzing something about the graph of the function. A quadratic equation, we set it equal to 0. That's when we're trying to solve the thing. We want to solve for x. So just a slight difference in vocab words and different uses for those things. So number three, let's do like a big mega example that connects some of the different things we've been doing lately. Here we have a quadratic function, y equals x squared plus 8x plus 15. The notes say for us to rewrite it as a quadratic equation, so we would have 0 equals x squared plus 8x plus 15. Now let's solve that quadratic equation by factoring. And that's what we did yesterday, so we'll take that x squared plus 8x plus 15. I'll put the equals 0 over here on the right side. We want to factor that thing. That's the easier kind of factoring because there's no number in front of the x squared. So we know it's just going to be x and x. We have to think of a couple numbers that multiply to be 15 and add to be 8. So I think it'll be plus 3 and plus 5. At that point, we set each of the factors equal to 0. And we solve them out. So I believe x would end up equaling -3, or x could also be -5. So you've got your two solutions there, kind of like you're used to. Let's keep moving along. When you factored that quadratic equation, you also did something else. You changed it from standard form to intercept form, which we did some last chapter in chapter 3, but this is standard form, and when you factor something, that's actually turning it into intercept form. So in intercept form, we're going to graph this, so I'm going to stick a y equals back on it, but we had a x plus 3 and x plus 5. Now let's graph it. When you're in intercept form, you can kind of automatically tell what the x-intercepts are going to be, -3 and -5. Hey, that's kind of familiar from what we just did. So we'll use those on our graph. -3 and -5 are the x-intercepts. And then you just want to find the vertex to finish off your graph. The x-coordinate of the vertex has got to be right in the middle of -3 and -5. So that would be -4. And then the y-intercept, when you take a second and plug a -4 into the equation, I believe you're going to get -1. So -4, -1 would be the vertex. You have your nice, lovely parabola over here. Now, the last part of this big example, let's make some connections between the solutions to a quadratic equation and the graph of a quadratic function. I'm guessing you already saw the connections, but the solutions to a quadratic equation are also the x-intercepts of its graph. The x-intercepts are also sometimes called zeros. This is actually true for all math equations, not just quadratics. And that's actually a pretty big deal. That's a big rule, and now and in your future math classes, that's a great thing to remember. If you ever want to solve some kind of equation and you might have forgotten how to solve it or something, you can always just graph it. And the x-intercepts are also the solutions to that equation. Hopefully your mind was blown by that. So now, number 4, all that's left to do is practice some examples like the ones that will be on your home. Basically, we're just going to solve a bunch of equations by graphing, now that we know that the x-intercepts are the solutions to the equation. Example 1, here is our quadratic equation. First thing you always want to do is get that thing in standard form, which means setting it equal to 0. So I'm going to subtract that 3 over to the left side. Now it's in standard form. When you graph something from standard form, you want to start with negative b over 2a. So that would be negative 2 over 2 times 1. When I simplify all of that out, it looks like it'll be a negative 1. We do that because that negative 1 becomes the x-coordinate of our vertex. Now you would take a minute, plug the negative 1 back into the standard form of the equation. I did it a minute ago, and when I did it, I got negative 4 for the y-coordinate. So negative 1, negative 4 is the good old vertex. And then the axis of symmetry, we know just heads right through that point. We also know the y-intercept is always this c number right here, so the y-intercept has got to be negative 3. Use a little symmetry to put another point on the other side. Unfortunately, we have the beginnings of a parabola, but we don't know the x-intercepts yet. And like we just discussed, the x-intercepts are the solutions, so we kind of need those. We really need those. So all you'd have to do at this point is just investigate another point or two. If you kind of follow the shape of the parabola, I'm pretty sure the x-intercept has got to be at 1 or 2. So let's try a 1. 1 squared is 1 plus 2, so that'd be 3 minus 3. Yeah, that'll give me a 0. Use a little more symmetry to get a point on the other side. We have graphed our parabola now. Sorry, I can't graph things very good on this tablet, oh gosh, that I'm using. So, even though my parabola is a bit wonky, we see the two x-intercepts are over at x equals 1 and x equals negative 3. Those are also the solutions to this quadratic equation. The x-intercepts are also always the solution. So we solved it by graphing it and looking at the x-intercepts. Example 2 is pretty similar. X squared plus 4x equals negative 4. First thing we want to do is make that equal to 0. And now in class when we did this this morning, a bunch of kids said, well, hey, why didn't we just take our equation and wouldn't it be a little faster to factor it, get it into intercept form, and then we just know the x-intercepts right away, which is a fantastic idea. So let's do that one. where we factor it. Let's do this one in that way. Plus 2 plus 2. So x plus 2, or whoops. So my x-intercept, that's what I meant to write, they're both going to do the same thing. They're both going to be -2 here. When that happens, when there's only one x-intercept, you know that point is actually your vertex. That's the only way there can be one intercept, is when your vertex is right on the x-axis. Without plugging in other points, we know the parabola is going to look something like that, but we already found what we needed to anyways. So x equals -2 is the solution to this equation. Okay, example 3. Same thing, solve by graphing. First of all, we need it in standard form. So I would probably add the x squared over to the other side. I think that'll be easier than getting everything to the left side. So x squared plus 4x plus 8. So in class, most everybody was like, hey, let's do it the way we did example 2 instead of the way we did example 1. That was kind of great. And I said, okay, give it a shot. So they started trying to factor, and within a few seconds, people were like, oh crap, that one doesn't factor because there's nothing that multiplies to be 8 that adds to be 4. So sometimes quadratic functions just don't factor, unfortunately. So we're stuck with standard form instead of intercept form. So we got to do our -b over 2a. So it looks like we'd get a -2. When I plugged that -2 in a few minutes ago, I got a 4 for the y value, and that is the vertex. So -2, 4. Also, from our standard form, we know that y-intercept is up at +8, which I'll estimate somewhere up there. Use a little symmetry. You have yourself a nice parabola. Now, we just got through saying that the x-intercepts are the solution to this equation, but there are no x-intercepts here. So this equation actually has no real solution, because there are no x-intercepts. So 3 things that can happen when you solve by graphing. And I showed them on our 3 examples. So first thing, there can be 2 solutions because there are 2 x-intercepts. Second thing, there can be 1 solution because there's only 1 x-intercept. The vertex is the x-intercept. And the third thing, some quadratic equations have no real solutions because there are no x-intercepts. Last thing, approximate the zeros of the function. I wonder why it says approximate and not solve. Let's see. Just to save a little time on the video, I did my -b over 2a and I got 0.5 when I did that. I plugged that in, and for the y coordinate I got -5.25. So there's the vertex. I'm going to draw the axis of symmetry heading down through the vertex. And I should go back. Unfortunately, this is another one that doesn't factor. So we are stuck in standard form. I know the y-intercept is -5. Boy, yeah, where's that x-intercept going to be? Let's try it positive 2. Well, I plugged it in a couple minutes ago on my calculator and there's the bell. I got negative 3. And then I said, okay, well, what about positive 3? The x-intercept's got to be over here somewhere. Well, I got a positive 1 at that point. So 2, negative 3, 3, positive 1. Use a little symmetry to complete the other side of your parabola. This is going to be another bad drawing. Ugh. I don't know why it's so hard to graph things nicely on this tablet. But anyways, now you can probably see why they said approximate the zeros, because the zeros they're not whole numbers. They're a little bit off. So I think on the board in class when I drew this, it was a little bit nicer then. It's a little easier on the actual smart board. But I think we said something like 2.8 is what we approximated it to be. And the other one we said about negative 1.8. So there are a couple like that at the very end of your assignment where the zeros aren't whole numbers, they're decimals. So you just approximate them to the nearest tenth. And that is it for 4.2. Thanks for doing some solving by graphing with me. You guys are awesome as always. Hope to see you back in class soon. Have a wonderful day.